Hey guys, we're going to do lesson 13's homework, and we're going to start off here with number 1 where it says classify each triangle by its side lengths and angle measurements. We did this today in class. Remember, each triangle has 2 names. So let's look at this first one. On triangle A, it looks like, and we could get a ruler to verify, but none of the sides are equal, so it should be scalene. And it's a right triangle because it has one right angle. Remember, all 3 have to be acute for it to be acute. Only one has to be right for it to be right, and one has to be obtuse. On B, all 3 sides are different, so it's scalene, and it has one obtuse angle. C, 2 sides are equal, these 2 right here, so that makes it isosceles. And we also know that it's acute because all 3 angles are acute. Okay, here it has the tick marks for us, all 3, so that means it's equilateral because all 3 sides are equal, and it's acute as well because all 3 angles are acute. All right, on number 2 it says triangle ABC has one line of symmetry shown. Is the measure of angle A greater than, less than, or equal to C? So if it has one line of symmetry and you fold that over, they're going to line up with each other perfectly since it's a line of symmetry. So we know that angle A is equal to C because if I folded them on top of each other, they would have to cover the same amount of space in order for that to be a line of symmetry. So I'm saying it is equal to angle C because they would fold on top of each other perfectly since that's a line of symmetry. Okay, part D says triangle DEF is scalene. What do you observe about its angles? So if it's scalene, and we talked about this today a little bit, well, let's go back. If it's equilateral, all 3 sides are equal, all 3 angles. If it was isosceles, 2 sides were equal and 2 angles are equal. And then if it's scalene, none of the sides are equal, which also means that none of the angles are equal. So I'm going to put all of the angles are different measures. Are different since all of the sides are. Or since all of the sides are not equal. Sorry, it's kind of hard to fit on here. Okay, let's look at number 3. It says use a ruler to connect points. Hold on one second. I'm going to have to lay a ruler on here. To form 2 other triangles. Use each point only once. None of the triangles may overlap. 2 points will be unused. Name and clearly classify the 3 triangles below. So I'm just going to pick some and I'm going to make some triangles. So let's see. I'm going to do A, B, D. Excuse me. Triangle A, B, D. And then let's do E, G, and F. Okay. Now I need to classify each of them by side length and by angle measurement. That means I'm going to have 2 names for each. And so let's see. Let's start off with I, J, K. It's kind of hard to tell if all of the sides are equal, but if I sit here and I count the grid spaces, so I see 1, 2, 3, 4, 5, 1, 2, 3. It looks like it's going to be scalene. Now I could be more precise and get out a ruler here, but from the looks of it and the way it's stretching, it looks like it's scalene because all 3 sides are different lengths. And at first I thought this was a scalene acute triangle, and then I had to go back and look at it again because I just assumed that they were all acute because angle I and K are very acute, but if you go back and you actually measure J, it's just a little bit obtuse. It's bigger than a right angle, so it really should be scaling obtuse. So you've got to be careful with those angles and make sure that you're using your protractor. All right, the next one I'm going to identify is EFG, triangle EFG. All 3 of those sides, 1, 2, 3. Well, first let's start off. There's a right angle at angle G right there, so I know for sure it's right. Now, if we were to sit here and measure all the sides, I'm pretty sure it's going to be scalene because none of the sides appear to be equal. And then if we went to A, B, D, this one, and you can measure it to check me, but I'm 99% sure it's equilateral. which means all three sides are equal, and it also means it's acute because all three angles are acute. All right, number 4 says, if the perimeter of an equilateral triangle is 15 centimeters, what is the length of each side? Okay, well, equilateral means all three sides are equal. So basically, I'm trying to figure out blank plus blank plus blank equals 15, because perimeter, we know, you add up all the sides. And so I need to know what's going to give me 15. So since they're all equal, I can divide 15 divided by 3, and I'll get 5. And so let's check that. If it's 5 centimeters, 5 plus 5 plus 5 will give me 15. So each side has to be 5 centimeters in order for it to have a perimeter of 15 centimeters. Okay, number 5 says, can a triangle have more than one obtuse angle? Now this is weird to think about, but if I draw an obtuse angle, well, no, because the third side wouldn't connect. So if you were to draw an obtuse angle, think about it. The two sides going away from the vertex are going to be so far apart because it's obtuse, they're not going to be able to connect unless it's with one straight line. So if I have two different obtuse angles, they're not going to connect. Let me draw a picture to kind of demonstrate what I'm saying. It's kind of difficult to explain, but I'm going to say no because the third line would not intersect to form the triangle. So here's an example. There's one obtuse angle, and okay, so if I don't just automatically connect those two ends and I make another one, that doesn't work out. You've already used your three sides and they're not connecting. So it can only, now I've got a trapezoid instead. So it has to have at most one obtuse angle. Last one says, can a triangle have one obtuse angle and one right angle? Well, let's see. Okay, let's draw a picture again. Obtuse, right. They don't touch because going away from it, they've got to come together at an acute angle in order for the sides to touch to become a triangle. It could be a different shape, but not a triangle. Say no, the third line wouldn't connect. All right, guys, good job. See you in the morning.